All right, so 111 is called the binomial theorem. It begins with a little bit of review, kind of putting some things together, and then it ends actually with the same. And then in between, we're going to learn something called binomial expansion, which is taking something, a binomial, which is two terms, and expanding it, like raising it to the third power, the fourth power, the fifth power, kind of stuff like that. So we start with a review, and this is if you pull in what you did on your project, okay, this kind of overlaps. So the factored form and the general form of an expression. If you think about what would be beneficial in each of those forms, it would help you to determine like how I want something written when I go to answer certain questions. So factored form is exactly what it sounds like. Something like x plus 2 squared times x minus 1 in fully factored form. When it's in this form, it's easier to find your roots because you would just split and solve it. So I would split these and set it equal to 0. It's easier to find my multiplicity because I'm looking for things to be raised to a power. It's easier to find your domain because it would be all real numbers except for, let's say if this was in the denominator, it would be all real numbers except for where those are 0. It would be easier to find vertical asymptotes if this was in the denominator because it's already factored, and then also wholes because it's already factored so we can cancel things out. General form or standard form is when it is expanded out. So if I had taken an expression and I had fully expanded it out, it would look like this. And for that form, it's easier to find the degree. For example, this one is 3. It's easier to find the y-intercept because if I just zero those things out, I get 0, -4. It's easier to find your horizontal and your slant asymptotes because you can easily spot what your n and your m are without having to expand it out. So one type of question you'll see, take it from factored form to expanded form and answer questions based on it. And then one would be the reverse. Take it from standard form into factored form and then answer questions based on it. So nothing new yet. This one says convert to standard or general form and then answer the questions. So you do this. Expand that out, find the degree, and find the y-intercept. All right, so what we can't do is distribute that exponent in, right? You have two choices, and that is I can write it as 3x minus 1 and 3x minus 1, and then FOIL that, and then distribute the -2. Or use your shortcut for squares, which is square the first term, that's 9x squared. Square the last term, it's +1. Double the product, which would be -3x times 2, so minus 6x, and then multiply that times -2. -18x squared plus 12x minus 2. That would be your standard form. So then from here, what's the degree? 2. And what's the y-intercept? 0, -2. Okay, all the terms with an x would get zeroed out, and I'd get just -2. Easy stuff, right? All right. Now, example 2 is the reverse. It's in factored form. It's in expanded form. It wants you to convert to factored form. What would you do first? Take out an x, and I'd get x squared minus 2x minus 3, and then that factors into what?
X plus 1 and x minus 3.
Good. X plus 1, x minus 3. Order doesn't matter. So it would be x times x plus 1 times x minus 3. So then what are the zeros from that form?
0, 1, 3.
Good. And to figure out where f of x is 0, you've got two options. One is kind of do your sign chart. Like I could take my 3 zeros, -1, 0, and 3, and I could plug in values. Something less than -1, something in between -1 and 0, something in between 0 and 3, or something bigger than 3. And then I could see if it's positive or negative. That's one option, okay? I would say for these, to make it a little bit less work, if the multiplicity on your zeros are 1, then it will be every other because it's got to cross through, cross through, cross through. So if I plugged in like a -2 and I got positive, now I know it's positive, negative, positive, negative. That's one option. The other is use your end behavior and visualize your graph. So if I do that, the my zeros I'm going to mark -1, 0, and 1, 2, 3, 3. Okay? I find my end behavior by looking at the highest exponent of my initial function. What's true about it? Good. It's odd and positive, so it falls left and it rises right. So my arrows fall left, rise right, and multiplicity on each of these is? Crosses through because it's 1. 1, 1, 1. Now I'm just looking for where it's greater than or equal to 0, which would be here and here. Good. I can say in interval notation, -1 to 0 with brackets because it's or equal to, and 3 to positive infinity. Or an inequality, -1 is less than x, which is less than or equal to 0, and x is greater than or equal to 3. So if it's multiple choice, obviously it could be one way or the other. And then if it's open-ended, unless it says write it in interval notation, both would be fine. Good so far? Okay. What's funny, well, not funny, but what's something to notice is a lot of questions, like very early on in our practice, like number 1 is a lot of time polynomials based on zeros. So like this could be number 1 on your AP exam, something like that, okay? Where it talks about zeros, multiplicity, and behavior, that kind of stuff. Okay, so here's what's new. And this is a process that once you understand the pattern, it's not bad, but in the beginning, it's going to be like, what the heck is she doing? You cannot go in and out. Ask I period. It was a disaster. Like I had 7 squirrels happening in the middle of the lesson, and then I had to redo it. Don't be that kid, okay? Because it will be very confusing to try to jump back in, okay? So we are expanding a binomial. Binomial means 2 terms. So we would take something like x plus 5 and raise it to a higher power than 2, let's say. If it's something like x plus y cubed, it's not that bad just to multiply it out. But if it becomes x plus y to the 5th, you don't want to have to write out 5 binomials and then multiply them out 2 at a time. And so we're going to learn a pattern. You're also going to see questions that say, what is the 6th term of the binomial expansion? And you don't want to have to go all the work to figure it out. So I'm going to teach you a trick with that, okay? But we got to notice things about this expansion. So the first thing says there are several observations you can make about these expansions. The first is n plus 1 number of terms. So whatever this exponent is, there are 1 more than that when I expand it. So if it's x to the 5th, there are 6 terms. If it's x to the 6th, there are 7 terms, okay? The second thing says x and y have symmetric roles. So we're saying x is our first term, y is the second role. It's symmetric. Where x is starting at 5 and working its way down, y is doing the opposite, starting at 0 and working its way up, which is what this one says. They increase and decrease in a symmetric pattern, okay? So x to the 5th is the first term, then it goes x to the 4th, then it goes x to the 3rd, x to the 2nd, x to the 1st, and x to the 0 would be the last term. So first term starts at the highest exponent, works its way down. Second term does the opposite. It starts at 0, then goes 1, then 2, then 3, then 4, then 5. Or they work their way into each other. That one goes 5 to 0, this one goes 5 to 0 from the right to the left. That's one way to look at it too, okay? The sum of the powers of each term equals the exponent on the original one. So this is just 5, that matches. This would be 4 plus 1, that's 5. 3 plus 2, that's 5. 2 plus 3, that's 5. 4 plus 1, that's 5, and then 5 by itself. Same thing happens here, okay? Each of those terms increase and decrease in a symmetric pattern, and all of those exponents can get added together to give you the 6 in that case. Now here's one thing that we have to find that's completely new, and that is the coefficients of the binomial expansion are called binomial coefficients. So new vocab term, okay? The binomial coefficient, think about coefficient, that's the number on the front, right, of this binomial expansion, are the numbers that are at the front of these terms. So there's no numbers here, right? Notice these are not just x's and y's. There's a number out of that. That pattern is called a binomial coefficient. There are technically 2 ways to find it, but no one ever remembers the first way, so I'm going to teach you a second way to find it, and that is using Pascal's triangle. We're going to follow a First thing we're going to do is expand without all this. So x minus 2 to the 3rd would literally be x minus 2 times x minus 2 times x minus 2. If it's to the 3rd, it's really not that bad to multiply it all the way out. I'm going to do it in the first 2 together. X squared minus 4x plus 4. And then multiply it times the last one. X to the 3rd minus 2x squared minus 4x squared plus 8x plus 4x minus 8. And I get x to the 3rd minus 6x squared plus 12x minus 8. So again, not terrible when it's something raised to the 3rd power, but that is not going to be an enjoyable experience if it's raised to the 6th, which is what the rest of the lesson focuses on. Questions so far? Okay. So here's the first part of each term, which is called the binomial expansion. So notice each of these terms. There's 3 parts to each term. The first is called the binomial coefficient. That's at C1. So this is C1, C2, C3, and so on and so forth. The second part is the first term raised to the highest power and then in decreasing degree. So if this was to the 10th, it would be whatever, a to the 10th, to the 9th, to the 8th, all the way down to 0. The third part is the second term raised to the 0 and then works its way up. So they go opposite directions. One starts at the highest, works its way down. One starts at 0, works its way up. Now that C comes from this chart, okay? This is called Pascal's triangle, and this is only to the 5th power, so I'm going to show you how to build it, okay? Because this will never get given to you. You don't need to memorize it. You just need to learn how to build it. So first of all, it starts with 1, 1, 1. That's your top little triangle every single time. Well, all of these are every single time, but this is where you'll start. Then every row after that, we add the numbers above it that feed into that cell to get the new cell. So it starts with 1, and then I add 1 and 1 to get 2, and it finishes with 1. Then it starts with 1, I add 1 and 2 to get 3, I add 2 and 1 to get 3, it finishes with 1. I go 1, add 1 and 3, I get 4, 3 and 3, I get 6, 3 and 1, I get 4, finishes with 1. Next row, starts with 1, add 1 and 4 to get 5, 4 and 6 to get 10, 6 and 4 to get 10, 4 and 1 to get 5, finishes with 5. Now if I'm going to the 6th power, I go another row. So let's fill in the next row together. It starts with what? 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10, 20. 10 plus 5, 5 plus 1, and ends with 1. Do one more row. 1. 1 plus 6, 6 plus 15, 15 plus 20, 20 plus 15, 15 plus 6, 7, or 6 plus 1, 7, and ends with 1. Okay? And you can keep building and keep building. The kids in the last class asked me if I have memorized. I don't have it memorized. I build it. Okay? Obviously, a couple rows become familiar, but I just keep going by doing the same thing we just did. Okay? So now, when I'm raising it to a power, whatever the power is the second number in the row. The first number is always 1. But if I'm raising something to x to the 3rd, for example, then I go to the row that starts with 1, 3, 3, 1. Because this is my exponent. If I'm raising it to the 6th power, I'm going to go to 1, 6, 15, 20, 15, 6, 1. If you do it wrong, you will not have the right amount of terms. If I raise something to the 3rd power, how many terms should there be? 4. So there's 1, 2, 3, 4. Like if I grab the wrong row, it won't match up. So hopefully that catches you, okay? So let's take what we just did in that last question. X minus 3. No, it was x minus 2, sorry. X minus 2 to the 3rd. And let's expand it out. So how many terms are there? 4. 1, 2, 3, 4. I literally give myself 4 spaces. The first term on each of these 4 is the binomial coefficient, which is 1, 3, 3, 1. The second term is the first term in my binomial coefficient. So in my binomial expansion, the first term that's in the parentheses, raised to the highest exponent, which is to the 3rd, down to 0. So it goes x to the 3rd, x to the 2nd, x to the 1st, and x to the 0. And then the third part, so every term has 3 parts. Binomial coefficient, first one, decreasing degree, second term, and this one you have to pay attention to that sign because that is a -2. And for this, we go the other direction. 0, then 1, then 2, then 3. And then we find the product of each individual term. So for the first term, I get 1 times x to the 3rd times 1, because that's what -2 to the 0 is. So it's just x to the 3rd. Then I get 3 times x to the 2nd times -2. multiply the constants, and I get negative 6x squared. Go to the next one. 3 times x times negative 2 squared, which is 4. Multiply the numbers together, plus 12x. And the last one, 1. X to the 0 power is what? 1. And negative 2 to the third? Negative 8. So this is minus 8. So same answer as the one we just got by expanding it. Questions so far? We're going to do it a couple more times. But questions so far?
Yeah, what's with the negative 2?
That's the second term. So first term was the x to the third, to the second, to the first, to the 0. Second term is negative 2. Negative 2 to the 0. 1, 2, 3. All right, this is just like where the binomial extension, where all the binomial coefficients go. So all the pink would be your Pascal's triangle, okay? This, which is basically what I talked about. You just didn't see it before. Okay, write the expansion of the expression. So how many terms are in this? 5. Give yourself literally 5 spaces. 1, 2, 3, 4, 5. Build Pascal's triangle. Don't just copy paste from what you have. The better, the quicker you, the more you practice it, the quicker you're going to get. So it's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. What's the exponent on my question? 4. So this is the row I stop at. 1, 4. So the first of each of these is 1, 4, 6, 4, 1. Then first term is 2x, and I do 2x to the 4th, then 2x to the 3rd, then 2x to the 2nd, then 2x to the 1st, then 2x to the 0. And then I get negative y. Negative y to the 0. Negative y to the 1st. Negative y to the 2nd. Negative y to the 3rd. Negative y to the 4th. And then we go term by term. So this is 1 times 2 to the 4th is 16. Times x to the 4th, and then negative y to the 0 is just 1. So this is 16x to the 4th. Then 4 times 2 to the 3rd, which is 8, times x to the 3rd, times negative y to the 1st. So we multiply 4 times 8 times a negative 1 technically, which means this term's going to be negative 32 x to the 3rd y. Then I go to the next one. 6, 2 squared is 4, x squared, and negative y squared is positive y squared. So I get plus 24 x squared y squared. Next one is 4 times 2 times x times negative y to the 3rd. And I get negative 8xy to the 3rd. And the last one, 1 times 2x to the 0 is 1 again. And negative y to the 4th is positive y to the 4th. So it will say, find, for example, the 5th term of a plus 2b to the 8th. What you don't want to do is expand it all the way out, okay? What I do want to do is figure out based on my pattern which term I'm looking at. So I start with my Pascal's triangle. If it's raised to the 8th power, I got to go all the way down to 1/8. Build it. Do it. Don't be lazy. Do it. Because the more you do it, the better you're going to get at it. We should have like racing. I should have prizes for who could do it fastest. Is that because you're slow?
Oh, shots fired.
You want to race me?
Me?
Mm-hmm.
Sure. Do you think I'm going to say no? Trying to call my bluff? All right, so I went to the 1/8 row. 1/8, 28, 56, 70, 56, 28, 8, 1. Technically, I didn't even need to finish it because I needed to get to which term? The 5th term. So 1, 2, 3, 4, 5. So the binomial coefficient is 70. Now I'm going to like literally draw the little blanks to the 5th term. So 1, 2, 3, 4, 5, just so that I can show you what I'm about to do. So we know already binomial coefficient is 70. Now think about what happens to the exponent of the first term. So in this case it would be to a. But what do we do with the exponent of that first term? Start at where? Start at 8, work my way down. So it would be 8, 7, 6, 5, 4. So the first term is going to get raised to the 4th. And then what do I do with my second term? I started at 0, 1, 2, 3, 4. What do you know about these exponents? They have to add up to what? To 8. So if I just did it the first time and I was really confident I did it right, then I could just do 8 minus 4 to get that second one. Okay? All right, so now I'm just looking at this term. That first term is a, so I'm going to raise a to the 4th. And the second term is 2b. I'm going to raise 2b to the 4th. And then I'll multiply that times 70. So 70 times a to the 4th times 2 to the 4th is 16 times b to the 4th. 16 times 70 is 1,120. A to the 4th, b to the 4th. Questions? Okay, you do the last one. On that last one, you could use a calculator if you want to multiply out. All right, so this time I want the 6th term, right? Which was, 6th term is 56 for my binomial coefficient. And then it's 8, 7, 6, 5, 4. First term to the 3rd, which means it would be second term to the 5th. First term is A, second term is 2B. And I'd get 56 times a to the 3rd times 32 times b to the 5th. And this is, what is it, 1792? 1,792 a to the 3rd, b to the 5th. How we do? Good? Okay. Guaranteed question on your AP exam, at least one. Okay, but most likely one, and it will be find this term, like 5th term, 6th term, whatever it is. Okay, so last question in the notes kind of just brings back what we did in the last couple of sections. And you'll see it like on the homework. It's like it says A and B. 11A, 111A is the binomial expansion, and then B brings back these kinds of questions because they're going to be back on your test. So it says in the xy plane, the graph of the function has a limit as x goes to infinity of f of x equals infinity. Which of the following could be the expression f of x? Well, first of all, what does this mean? What does limit as x goes to positive infinity f of x equals infinity mean? Good. It's explaining the right-hand side of my end behavior, right? We all understand that? And we're saying it goes up. So I'm looking for of these, and this is a mix between rational functions and polynomial functions intentionally. You're going to see them mixed in. So let's talk about the end behaviors here. If it's polynomial, so we're talking B and D, let's start there, okay? We're looking for the degree, and then if it's positive or even or odd, positive, negative, right? So for B, my leading term would be -2 times x to the third times x. So this would be negative 2x to the fourth. What would the end behavior be on that? Both would go down, so that doesn't work. Then I go to D, right? And this time it'd be a positive, it's an x to the first, an x to the third, and an x to the first. So this would be x to the fifth. What kind of end behavior does positive x to the fifth have? Falls left, rises right. This one matches what we found, okay? Let's say it was which of the following does not, or and we would have to keep going. Let's go to the rational functions. How do we know end behavior on a rational function? It's based on the horizontal asymptote. Good. So I need to know that this would be x to the third in the numerator over x to the fourth in the denominator. What's true about my n and m? N is less than, so y equals 0 is my horizontal asymptote, which would mean the end behavior is 0. I rule it out. Go to C, this would be x to the fourth over x to the fourth. My n and m are? They're equal, so my leading coefficient would be y equals 1, and my end behavior would be 1, which rules it out. So D is the only one in which the end behavior, as it goes to positive infinity without bounds, would be to positive infinity. Good? That's a great example of an APPC question. Okay. On